Hi, welcome back to another Blazor build in which we build an accessible data table, also termed a data grid. I'm calling this build a data table as it aligns with the ARIA authoring practice guidelines for the table pattern and not the data grid pattern. The data grid pattern is for Excel spreadsheet-like grids where every cell is editable, requiring differing keyboard support that assistive technologies and their users have come to expect. And as I had no plans for making every cell editable, I chose the table pattern. This build is in two parts, with the completed source code already available to download from GitHub. The first part, this video, demonstrates the Dable table's features, ending by discussing and showing the basics of how you go about creating a data table or data grid. Part 2 of this video should be uploaded in a few days, in which I will thoroughly go through the code so you can implement what is demonstrated yourselves. The only caveat is that I would recommend that you are comfortable with the basics of building a data table as shown later in this video before trying to add any bells and whistles. Normally, for simplicity, I use the Blazor web app template selecting the Blazor server option, but for this build I chose the Blazor WebAssembly option so we can make calls via a gRPC service to get the data for the grid from a database. However, this was not the main reason that I chose the WebAssembly option. The main reason was that I knew operations such as filtering and sorting are much slower on WebAssembly than they are on the server. This does not mean in practical terms that WebAssembly grids are slow. It just means that we will be viewing the slowest application type of the two, so you have an idea of how much data you can actually load and operate on with zero performance issues. Right, let's dive in and start with the basic table. No paging, filtering, templating or styling, just a scrollable table with sortable columns. The format for each part of the demo is the same. We have a simple ad hoc search form component that when submitted just calls a gRPC service. Once on the server, we query a small SQLite database file that has a single table with 50,000 rows in that we can have returned. As mentioned in my gRPC video, a cold start will incur about a 1 second penalty to get the channels set up for the entire application, after which it's pretty quick. So let's get that out of the way first. I know that when using a search criteria with the first name starting with the letter J, it returns just over 5,000 rows, so let's use that to warm up the system. As you can see from the information below the grid, we got 5,120 rows in just over 1.5 seconds. Not too bad. Let's try that again. We're now under half a second. And for 50,000 records? Just over 3 seconds. And when I last looked at the dev tools, it showed about 4 megabytes being transferred for that search. Our table has fixed headers, so they are always visible, and for the demo I made all columns sortable. Presently no column has been sorted. By default and without any paging, the table uses the Blazor virtualization component, but you can turn this off if need be by setting a component parameter virtualize item size px to 0. I also added code to show the table's internal spinner when sorting or filtering on more than 2,500 rows. Sorting 50,000 rows takes a couple of seconds, borderline for my patience. The code does a stable sort, meaning it uses the position index for tiebreakers, so it always returns the same sort order for the ties. This makes it about 40% slower than an unstable sort. Let's go back down to only using 5,000 rows and try again. No problem. Let's see it without the spinner when there are less than 2,500 rows. Just under 1,500 rows. Blink and you'll miss it. Before we move on, I should point out that you can set a column to be sorted on load. Also, the table stores the index of the last column that was sorted on, so during a new load, the data will automatically sort on that column. Let's review the markup for this configuration of the data table. We have our busy indicator component, the ad hoc search demo component, and then our data table. The data type tData is a customer search result object. The default sort index is less than 0, the default, so no sorting on load. The data source parameter is set to use a list of customer search results, with the required ARIA table title parameter supplied, but we have opted not to show this to sighted users. Each data property column uses an expression to get the property name for the column name, and uses reflection to get the property values. If the display name is not set, the data property value is used for the column header. All columns have been set to be sortable, with the date column using both formatting, the standard string format types, as well as an alignment option for the column. When the search is submitted, the busy indicator is shown, and we send our query via a service that uses gRPC. We then receive the results and update our search results variable that the table uses, finally hiding the busy indicator. Nothing complicated. Next up, the styling options that are available, excluding just altering the data table style sheet, of course. You can pass a string value to either the header style or cell style parameters, which are used to populate the style attribute on the respective th and td elements, or for a more dynamic approach, you can supply a function for the row style func or cell style func parameter, which gets provided with the row data. This allows your function to set a style dependent on certain data values. For this demo, I have added a row style function that sets the row's text colour to be red when the surname is James and their country is the United Kingdom. I also added a function for the cell style func parameter that sets the table cell's background colour to a light blue and the font weight to bold when the customer is Paul Daniels. Let's review the markup changes for this configuration. On line 27, you can see the row style func parameter being set to the private field row style function, and on line 32, the cell style func parameter being assigned the private field cell style function. I would have liked to have used a named delegate, so you could have also used a method, but Blazor did not allow that. Not mentioned during this part of the demo, but I also set the date column's header style to have a minimum width of 15 characters, as seen on line 36. Next up, paging and filtering. My typical setup is a filter and a pager at the bottom. For this demo, I have included both a top and bottom pager in differing configurations. Over the years, I have come to like the simplicity of just a single filter that checks every field to see if it contains the text entered. So that's how I've configured the filter for this demo. Obviously, the less rows, fields that you check, the quicker the filtering will be. Let's start with a search using the letter J to get 5100 rows back to see what filtering across every field is like. Well, that seemed fine to me. How about the full 50,000 rows, again entering the same filter text? Given the amount of rows, I think that's acceptable. Okay, what about paging? Let's really stress it by using the keyboard and holding down the Enter key. I think that's quick enough. While we have the pages and filters, let's turn on the free screen reader NVDA and listen to what it sees.
Speech mode beeps. Speech mode talk. Document. First name, edit optional, starts with the entered characters. Blank P, A, U, L. Surname, edit optional, and starts with the entered characters. Blank C. Company name, edit optional, and starts with the entered characters. Blank. Search button. Searching. Search completed. 15 results returned. Page 1. Entries 1 to 10 of 15. Filter customers. Edit table will update as you type blank. Customer results page navigation landmark list with 3 items. Previous button unavailable. Next button. Customer search results. Table with 15 rows and 5 columns. Row 1 column 1 first name button. Sorted ascending. Sorted descending. Column 2 surname button. Sorted ascending. Column custom filter customers. Edit table will update as you type blank. C. Page 1. Entries 1 to 7 of 7. Filtered from 15 total entries.
Let's review the additional markup that was used to enable paging and filtering.
Blazor builds. Microsoft Visual Studio window. Tab control. Filtering paging. Razor. Speech mode on demand. Speech mode off.
When I built the data table, I just added name render fragments, top pager, filter and bottom pager, so you could add a pager or filter that would be contained within the data tables containing div, but it's not a requirement to do so. Both the pager and filter are standalone components that we built earlier, and you could place them anywhere on the page. And as each of these components have their own dedicated video, I'm not going to go over the configuration options available. On line 29, I have set the filter rule parameter to use the filter rule private field, a function that accepts a customer search result and returns a boolean. This predicate is then built on line 69 in response to an event raised by the text-debounce component. On line 30, I added the top pager tag and the pager component use its compact display. To link the pager to the data table, we use the paging info object as seen on line 63. This just has properties for the pager that the table then reacts to or updates, such as when filtering or sorting. On line 34, I added the filter tag and the text-debounce component using a delay of 300 milliseconds. I would suggest raising this to 400 or 500 milliseconds if you are planning to filter across more than 50,000 rows. We then assign our event handler handleDebounceText to the onDebounceText parameter. For those who watch the Debounce filter build, you may remember that instead of using an event callback that would cause a render, we used a func instead to negate this. If you look down at line 69, we do a check to see if the debounce text is valid, and only after that check do we build the rule and raise status changed. If we had used an event callback, just having the handler would have caused a render to our data table, irrespective of the validity of the debounce text result. Line 46 shows the inclusion of the bottom pager, this time using the largest display option, including the input box. The only other thing to note, and something that I forgot to add when making the text-debounce filter video, was a method to clear the text held by the filter's text input. I have since added this and updated that repository. I mention this as, although not shown, within the handle search method I call the clear text value method, which clears the filter input without it raising any event. There's a little nuance in using this separate filter. The data table checks and compares its currently assigned filter rule and its previous filter rule. It does this so as not to refilter every time a render occurs, such as when paging, as the code holds a separate filtered collection for sorting and paging. When the user does a new search, a new data source is provided to the data table, and as the filter rule has not changed, irrespective of any text held in the filter text, no filtering occurs, which is the behavior that I wanted for a new search. However, if there is text in the filter's input, it looks odd, as the new search results have not been filtered. Hence I clear the filter's text to reset everything. If you do not like this nuance, you can simply embed the filter component within the data table markup with the option to show and hide it, allowing the data table to access the clear text value directly. Okay, let's move on to row selections. To keep things simple for accessibility and keyboard-only users, selections are based on checkboxes, with mouse users being able to click anywhere within a row to select or deselect it. For the demonstration, I will use the keyboard to select a few rows and then switch to the mouse to select others. Selections and deselections are added and removed from a collection of selected items which is provided to the parent component via an event. This collection persists during paging and filtering, but is cleared if a new data source is provided to the data table. You have the option to use either single or multi-select, with single selection just ensuring only one item is in the selected item collection, but otherwise it's the same functionality. Both the checkboxes and column header have an ARIA label so assistive technology users know what they are for. I place the checkboxes after other columns, but it's simple to change this if you want it to be the first column. Let's look at the markup configuration used for the selections. On line 30 we have set the selection mode to multiple, the default being none, and then use the bind syntax for automatic two-way binding of the selected rows parameter to the private field selected rows on line 76, and that's all there is to it. If we scroll down a bit, you will see an unused event handler on line 114 for the selected row changed event. You have a choice. You can either use the bind syntax as shown or the event handler, but not both. Next up is templating. For this demo I just added a custom column so we can have a button to delete the row, as well as adding a cell template to the country column so we can have a Union Jack icon and a link to the Buckingham Palace website if the country was the United Kingdom. Regarding the custom column, in production where I generally have more than one row action, I would include the drop-down menu button that we previously built. If you watch that build video, you will see it in action on a table. Let's review the markup required for that part of the demo. On line 89 we added a cell template with its context containing the tData object, which is a single customer search result object which we can access. In this instance adding a link if the country is the United Kingdom. On line 105 we add a new column of type data template column, which is not part of the data source. More on that in the next video. And again, using a cell template, we add a delete button. This column type also allows for a header template to be added, but in this instance I have not used it, so the standard display is used for the column's display name. Sorting is not available on template columns. That concludes the demo, so let's turn our attention to how you actually go about building a generic data table. The simplest way, and which is applicable to a lot of components, especially when this is all new and confusing, is to actually start at the end and work backwards. What I mean by this is add the markup that you eventually want and then start converting it to be generic, adding the appropriate component parameters when needed. To illustrate this, we will convert the Blazor's template weather table to become a generic data table, using its output as the guideline of what we want to see if this generic data table was assigned a collection of weather forecast objects for its data source. Before we begin, it should be noted that the Blazor template uses the Bootstrap CSS framework, so the tables on screen are just picking up those styles. The data table component just demonstrated does not use Bootstrap, it uses its own styles. Let's review the markup for the three on-screen tables, step 1 being the top table, the default Blazor template code. The middle table, step 2, is our first component that still contains some hard-coded parts, with the last table being the output from our finished step 3 table component, a fully generic data table. At the top of the screen is the markup copied from the weather page. It has static heading text and a for each loop to create each table row, with a hard-coded fixed number of columns that gets the data by accessing the typed weather forecast object properties. The step 2 table component has a data source parameter set to use a list of forecasts. Last is the finished generic step 3 table component that has a type parameter tData set to use weather forecast, with its data source set to use a list of forecasts. This component also has a named render fragment data table column, where we can define our table column components for each column that we want to see. This component has a title parameter for the text used for the table headers and a field name used to access the weather forecast object properties by name to get the data for the table cells. Let's look at the code in our first component, the step 2 table component. No drastic changes. We still have the static heading text that we need to turn into a looping structure. We have changed the for each loop to use a generic list with the type param attribute at the top of the page specifying that we have named this tdata. Our data source on line 47 is a list of tdata. We still have the fixed number of columns, but now we use reflection to access the object's properties by name to get the values. What we would also like is another looping structure, so we can do a for each on a collection of columns, with these columns containing the metadata that we can use for both the column headers and for accessing the property values. Let's look at creating a column component for this metadata, using component parameters to capture the values supplied by the user. Our table column component in this instance is just a class that inherits from Blazor's component base class, as we do not require any markup. You can use a Razor file and its code block if you prefer. We are going to put all of the markup in the parent component, the step 3 table component. We know that we will need a collection of columns, and as such, the column class is not the place to define this collection, so we will need to have this available in the parent component. The question now becomes, how do we add the column to a collection held on the parent component? One way that we can achieve this is by having the parent component define a cascading value so it can pass a reference to itself down to any column components. The columns can then use this reference during their uninitialized lifecycle method to add themselves to the parent's column collection by using a method that the parent provides. The cascading parameter parent table on line 7 of type step 3 table tdata is the property that will get assigned with the cascading value, the reference to the parent component. The other two parameters will hold the values needed for the column headers and the field name of the property that we want to access on the tdata type. Next is the step 3 table parent component. There is a little more code compared to the step 2 table component, but there's nothing difficult. We still have the type param, but now introduce a cascading type parameter, so we can have this type cascaded down to our column components. This has nothing to do with the cascading value. It's more of a helper, so we do not need to add tdata equals weather forecast in the markup for every column. Using this attribute allows Blazor to infer the type for the columns. The cascading value component is used to pass the reference this, the step 3 table component, to the child column components. As our table column component doesn't have any markup, we do not need to wrap the parent's markup with the cascading value, which is what we would have done if it had markup and that markup needed to be output in a specific place. On line 44 we have a collection for our columns, so we can now use this collection to add a for each loop to build the table headers using the values supplied to our table column component's title parameter. We can also use a for each loop to build the TD elements of the rows using the value assigned to the field name parameter to access the property value of the tdata type. On line 42 we have a named render fragment data table columns. We gave this a name instead of just using the default child content, so a tag name data table columns has to be added, in which content is then placed. Using child content doesn't require any tag for the content. It can be placed directly within the step 3 table tag itself. On line 46 is the method that each column uses to have themselves added to the collection of columns. One important aspect to understand when dealing with parent-child components is the order of events. The parent component is initialized first and then starts rendering before the children are even initialized. They get initialized during this process, generally when encountered. In our case, the parent can't render the markup for the columns until they are in the collection. So that's why on line 15 I just put a statement saying if we have no columns, just exit. If you look at line 57 within the onAfterRenderLifecycle method, we do a check to see if this is the first render, knowing that the first render didn't initially have access to the columns. At this point, the child components will have been initialized and added to the collection. Just adding columns to a collection will not cause a render, so we have to request Blazor to perform a render. We do this by calling statusChanged. Now everything is output as expected. If you were to put a breakpoint on the ifDataTableColumns.count equals 0 that's within the markup code and another on the addColumn method, you will see the markup code is run before any columns are added. Now you have seen the code, let's go back to the component markup, as it should be a lot clearer now. In part 2 of this video, we will go through all of the code in the data table component. There's a lot more markup and code, but fundamentally it's exactly the same as what we have just done for the step 3 table component and its child R table column component. If you fully understand what we have just done, then you're capable of building a data table with additional features. If you have not watched the pager or debounce filter videos, I would suggest you watch them before part 2 of this video, so you don't get distracted wondering how they work when we go through the data table code. Hopefully speak to you again soon in part 2. The full source code for the demo is available to download from GitHub if you want to inspect it and/or see how it performs on your machine. And as mentioned, I copy-pasted the pager and debounce filter components from the other builds so you could step through anything if needed. Until next time, bye for now.